Hello everyone, welcome back to the lecture series on business mathematics. As you know that this is our sixth lecture of this lecture series. Let us quickly recall what we discussed in the last lecture. As you know that in the last lecture we defined what is called the harmonic progression. Let us quickly recall the definition of harmonic progression. Suppose we are having non-zero numbers a1, a2, a3 and so on, right? These are non-zero numbers. These numbers are said to be in harmonic progression if their reciprocals, that means 1 upon a1, 1 upon a2, 1 upon a3 and so on. These are in arithmetic progression, right? That means if the distance between consecutive distance between reciprocals are same, then we say that the numbers a1, a2, a3 are in harmonic progression. Okay. We also discussed that if we are having three numbers a, b, and c which are in harmonic progression, then we say that b to be the harmonic mean of a and b. Right. We also discussed the formula to find out the harmonic mean. Suppose we are given that h is a harmonic mean of a and b, then h can be written as twice AB divided by A plus B. We also derive this formula to find out the harmonic mean between two numbers, right? So once again, what do we mean by harmonic progression? The numbers, non-zero numbers in fact, because we are taking reciprocals here. That's why this A1, A2, A3 must be non-zero. So the numbers A1, A2, A3 are said to be in harmonic progression if their reciprocals are in arithmetic progression, right? We also discuss an example. We have taken two different numbers in terms of x and y, and we try to find out the harmonic mean of these two given numbers, right? Let us continue discussing the examples on harmonic mean. Let us see one more example. So the question is, if h is the harmonic mean of a and b, if h is the harmonic mean between a and b, then find the find the value of h upon a plus h upon b. Find the value of h upon a plus h upon b. And what is the question? We are given that h is the harmonic mean between a and b, right? So let us note down the fact. We are given that h is the harmonic mean. H is the harmonic mean between A and B, right? This is we are given. What is the question? We are asked to find out the value of H upon A plus H upon B. Just now we discussed that if H is the harmonic mean between A and B, then H can be written as twice AB divided by A plus B. So we'll use this formula. We'll use this formula. So therefore, H is equal to twice AB divided by A plus B. Now what is the question? To find out the value of h by a plus h by b. So let us see, therefore h upon a plus h upon b, right, is equal to, instead of h we will use this formula, twice ab divided by a plus b. So twice ab divided by a plus b whole divided by a, plus again h, it is twice ab divided by a plus b whole divided by b. Okay, so let us simplify this. So this is equal to, you can observe that this term is in numerator, right? These terms are in numerator while this is in denominator. So we can observe that this a will be multiplied with a plus b. So simplifying this, we will get twice ab, a into a plus b, plus again this b will be multiplied with this. So twice ab divided by b into a plus b. Okay, so in order to make the denominator same, right? In order to make the denominator same, what we will do, we'll multiply and divide this term with b. We'll multiply and divide this term with a. So this will be ab into a plus b. Again, this will be ab into a plus b. So we can easily add the numerator. So multiplying the numerator with b, what we'll get? 2a into b. So it is 2ab square plus, here multiplying this term with a, so we'll get 2a square b, and denominator will be same, it is ab into a plus b, right? Ab into a plus b. So you can observe that from numerator we can take 2ab common out, right? We can take 2ab common out. So twice ab is common out. What is remaining? B plus a. From this we are having b, from this term we are having a, divided by ab into a plus b, right? You can observe that this a plus b get cancelled out, a get cancelled out, b get cancelled out, right? So what we are getting? We are getting that therefore h upon a plus h upon b is equal to 2, and this is your answer, right? It is just a matter of simplification, nothing else. But you must have to remember the formula for h. If you don't know the formula, you cannot move further, right? So it is important to remember the formulas. So again, h is equal to twice ab divided by a plus b. So putting the values in h by a plus h by b and simplifying that, the value of h by a plus h by b is equal to 2, and this is your answer. Okay, so I hope the solution is clear to you. Let us see one more example. Let us see one more example. The question is, insert three harmonic means. Insert three harmonic means between -2 and 2 by 11. Right? Insert three harmonic means between -2 and 2 by 11. Right? So we are given two numbers. Say this is A and say this is B. And the question is, we have to add three harmonic means between A and B. Right? That means we have to find out three numbers, say h1, h2 and h3, such that A, h1, h2, h3 and b, this must be in harmonic progression, right? This is what the definition. We have discussed in the last lecture that suppose A, h1, h2, h3 up to hn is in harmonic progression, then h1, h2, h3 up to hn are said to be harmonic means between A and B. Okay, so in order to insert these three numbers, and this must be harmonic means, so it implies that this progression must be in harmonic progression. Okay, so we'll find out three numbers h1, h2, h3 such that this is an harmonic progression. Okay, so let us see the solution. We are given two numbers only, first number and last number. Okay, so let h1, h2, h3 be harmonic means between -2 and 2 by 11, right? What does this mean? By definition, therefore, -2, h1, h2, h3, 2 by 11 are in harmonic progression. By definition of harmonic means -2, h1, h2, h3, 2 upon 11, this will be in harmonic progression. Okay, so these numbers are in harmonic progression. So by definition, -1 upon 2, 1 upon h1, 1 upon h2, 1 upon h3, and reciprocal of 2 by 11, that will be 11 by 2, are in arithmetic progression. Okay. Now see, these five numbers are in arithmetic progression. So we are having that n is equal to 5 because these are five terms. We are having the value of first term a1, that is minus 1 upon 2, and we are having the value of a5, an, that is a5, that is equal to 11 by 2, right? This many things we are having. Now our aim is to find out the value of d, the consecutive distance between these terms, right? Since these are in arithmetic progression, the consecutive distance will remain constant. So now the question is to find out the value of d. Once we get the value of d, we can easily find out the values of h1, h2, h3 and so on. Okay. So how to find out the value of d? We'll use the formula to find out the nth term of an arithmetic progression. So we know that the nth term of an arithmetic progression is given by, what is the formula? An is equal to a1 plus n minus 1 into d, right? Now you are having the value of n, you are having the value of an, you are having the value of a1, right? Putting all these values in this formula, you will get the value of d, right? So an, instead of n we are having a5, so therefore a5 is equal to a1 plus 5 minus 1 into d. Now what is the value of a5? A5 is equal to 11 by 2. So it is 11 by 2 is equal to a1 is minus 1 by 2. 5 minus 1, that is 4 into d as it is. Now we want to find out the value of d. So we'll solve this equation for d. So what we'll do, we'll take this term on left hand side. Instead we can say that we are adding 1 by 2 on both the sides. So what will you get? 11 by 2 plus 1 by 2 is equal to, this 1 by 2 get cancelled out, 4d, right? Now see, the denominator is same, 2 2. So we'll simply add the numerator, 11 plus 1, that is 12, divided by 2, and this 4 is in multiplication on right hand side. Taking on the left hand side, it will be going denominator. Instead we can say that we are dividing this equation with 4 on both the side. This is equal to d. You can observe that 4 3s are 12. So d is equal to 3 upon 2. So now we are having the value of d for this arithmetic progression, right? Value of d for this arithmetic progression. Now it is easy to find out the value of second term, third term, fourth term and so on. Why? Because we know that suppose a is the first term, suppose that a is the first term of an arithmetic progression, then a1 is the first term, then what will be a2? A2 will be a1 plus d, right? We have already studied this. What will be a3? Is a2 plus 2d, then sorry, a1 plus 2d, first term, right? A4 will be a1 plus 3d and so on, right? Now we are having the value of t, we are having the value of a1, so we can find out the value of a2, a3 and a4. So let us see. Now a2, see here the first term is a1, that is 1 by 2. What is a2? It is 1 upon h1, right? So a2, that is equal to 1 upon h1 is equal to a1 plus d. So 1 upon h1 is equal to a1. We know the value of a1. A1 is equal to minus 1 by 2. It is minus 1 by 2 plus d. What is d? It is 3 by 2. So again the denominator is same. So what will happen? So therefore 1 upon h1 is equal to 3 minus 1 divided by 2. So 3 minus 1, that is 2 upon 2. So it is 1. Now see, this is the value of 1 upon h1. What we want to find out? We want to find out the values of h1, h2 and h3. In order to find out the value of h1, We'll take the reciprocal of this term. So reciprocal of 1 is 1. So we are having the value of h1, that is 1. Now a3. What is the third term? It is 1 upon h2. So a3, that is equal to 1 upon h2. And what is the formula? A1 plus 2d. Right? So therefore 1 upon h2 is equal to a1. Again it is minus 1 by 2 plus 2d. What is d? 3 by 2. Right? So see, we will not cancel out 2 here because we want to make the denominator same. Right? So simplifying this, minus 1 plus 3 into 2, that is 6 divided by 2, and 6 minus 1, that is 5 divided by 2, and this is the value of 1 upon h2. So what will be the value of h2? Reciprocal of 5 by 2, that is 2 upon 5. So the value of h2 is 2 upon 5. Similarly, a4, what is the fourth term? This one is first, second, third, and this is our fourth term, 1 upon h3. So this is 1 upon h3. And what is the formula for third term? Sorry, fourth term. It is a1 plus 3d. What is a1? What is a1? It is minus 1 by 2 plus 3d. 3 into 3 by 2. So therefore 1 upon h3 is equal to, again denominator is same, so we can directly add the numerator, minus 1 plus 3 into 3, that is 9 divided by 2. 9 minus 1, that is 8. 8 divided by 2, that is 4. This is the value of h3. 1 upon h3. So h3 will be reciprocal of 4, that is 1 by 4. Right? So you can observe that we have already find out the values of h1, h2 and h3. Right? So therefore, therefore h1 is equal to 1. What is the value of h2? It is 2 by 5. And h3, that is equal to 1 by 4. h3 is equal to 1 by 4 are harmonic means between minus 2 and 2 upon 11, and this is your answer. Okay, this is your answer. I hope the solution is clear to you. What we did, we are asked to find out the harmonic means between two given numbers. So we have assumed that h1, h2, h3 are harmonic means between these given two numbers, right? So their reciprocals will be in arithmetic progression. Now we know the formula to find out the nth term of an arithmetic progression. Using this formula, we find out the value of consecutive difference. Once we get the value of d, we know that a2 is equal to a1 plus d. So we get the value of 1 upon h1, and taking reciprocal, we are getting the value of h1. Similarly, using the formula for a3 and a4, we are having the value of h2 and h3 respectively. Right? So this is your answer. Okay. So I think the solution is clear to you. Let us move further and let us define now what is called the geometric progression. Geometric progression. Okay. So let us see the definition first of all, and then we'll try to understand it. So let a1, a2, a3, and so on be given sequence. We say that a1, a2, a3, and so on are in geometric progression. Right? Simply we will write GP, right? These numbers are in geometric progression if the ratio between any two consecutive term ratio between any two consecutive terms is same, right? Okay, let us try to understand the definition. We are having a sequence A1, A2, A3 and so on. And we will say that these numbers are in geometric progression if ratio between any two consecutive terms, right? Ratio means second term divided by first term, third term divided by second term, and so on. Okay, so once again, in arithmetic progression, we are having that consecutive difference remains same, while in geometric progression, the consecutive ratio remains same. Okay, so if A2 upon A1 is equal to A3 upon A2 is equal to A4 upon A3 and so on, then we say that this given sequence is a geometric progression. Okay, for example, if A is the first term of a geometric progression and R is the consecutive ratio, then the geometric progression the geometric progression is given by what is the first term? A. What is the second term? R. So second term will be A into R. You can observe that AR upon A, that is R. R is the consecutive ratio. What should be the next term? It should be AR square because AR square divided by R. So it will be R again. Next term will be AR cube. Then AR raised to 4 and so on. Right? So this is the general form of a geometric progression. Now you can observe that in first term we are having A into R raised to 0. Something raised to 0 is 1. Right? In second term we are having A R raised to 1. In third term we are having A R square. In fourth term A R cube and so on. So we can observe that the nth term of a geometric progression is what will be the nth term? See, A is common in all the term. So A will be there. Now see the power of R. In first term, power is 0. In second term, power is 1. In third term, power is 2. In fourth term, power is 3. So you can observe that the power is less than the number of term. So in first term, power 0. In second term, power 1. So what will be in nth term? Power will be R minus 1. Sorry, n minus 1. Okay, so we can observe that in the nth term of a geometric progression will be a r raised to n minus 1, where a is the first term and r is the consecutive ratio. Okay, so I hope the definition is clear to you. Once again, quickly let us quickly recall the numbers a1, a2, a3, a4 are said to be in geometric progression if the consecutive ratio remains same. That means a2 by a1 is same as a3 by a2 is same as a4 by a3 and so on. We can observe that the general form of a geometric progression is given by AR square, AR cube and so on. And the nth term of this geometric progression will be A into R raised to n minus 1. Okay. Now let us see the sum of first n terms of a geometric progression. Okay. Sum of first n terms of a geometric progression. Okay. So for that, let A AR, AR square, AR cube, and so on be given geometric progression, right? Then the sum of first n terms is given by, now see, there are two different formulas for having the sum of first n terms of a geometric progression. The first one says that a r raised to n minus 1 divided by r minus 1. Another formula says that a 1 minus r raised to n divided by 1 minus r. Now see this, we are having these two different formulas. So the question is when to use which formula. So if the consecutive ratio is greater than 1, if consecutive ratio is greater than 1, then we'll use this first formula. If the consecutive ratio is less than 1, we'll use the second formula. Okay, you can observe that there is a difference between sign here only. This is r raised to n minus 1, this is 1 minus r raised to n, right? Divided by r minus 1, and this is 1 minus r. Okay, so if r greater than 1, we'll use this formula. If r less than 1, we'll use this formula. Okay, now the question is what happens if r is equal to 1? What happens if r equal to 1? Okay, so see in any of this formula, put r equal to 1. What will you get? 1 minus 1 divided by 1 minus 1. So this is 0 upon 0. Similarly here, 1 minus 1, 1 minus 1, 0 upon 0. Now we are going to discuss in the last unit of our syllabus that 0 upon 0 is an indeterminate form, right? That means you cannot have the fixed value for such kind of terms, and these terms are said to be indeterminate forms. Okay, you cannot determine the value of such terms, that's why indeterminate forms. Okay, so 0 upon 0 is said to be an indeterminate form. We are going to study 7 different types of indeterminate forms in the last unit of our syllabus. In case of r equal to 1, we cannot find out the sum of first n terms, right? That's why we are not considering the case r equal to 1. So I think this is enough for today. We'll continue discussing examples of geometric progression in next lecture. Thank you.